All right. So Stewart, book 5E, section 3.4. It's on related derivatives. Number 4 is what I'm going to do. The whole 1 through 6 has the same instruction. The particle moves according to a law of motion, S equals F of t, where time has to be greater than or equals 0. T is measured in seconds. S is in feet. So our units will be feet for distance, feet for position, feet per second for velocity in this problem. That's what I know immediately. And it has 6 parts, A, B, C, D, E, F. And part A says find the velocity at time t. And again, what I want to recall immediately is we're given a position for here, a function that gives position. And it's giving feet. So the y-axis would be in units feet. The x-axis would be in units of seconds. And again, if you take a look at a line, the secant line, you're going to see that the slope is going to be in feet per second. So the derivative at any given point is going to have units of feet per second. So all I have to do is use the power rule to do letter A and on the position function. So if I pull 4A up here, the function was t to the 4th minus 4t plus 1. The derivative of t to the 4th is 4t cubed. Derivative of negative 4t is just negative 4, and derivative of 1 was 0. And just like that, I have found v of t, the velocity function. And it's going to have units of feet per second when we do the work. So letter B says, what is the velocity after 3 seconds? Well, just plug 3 in there. It's just a function notation. So v of 3 is question mark, so I put 3 in. I do the work. Quick and easy. And next thing you know, I have an answer of 104 feet per second. So I just did A and B. And again, fairly straightforward problems. Now the next problem is, when is the particle at rest? Well, the particle is at rest when it's not moving. That happens when the velocity is equal to 0. All right? So when I work through the steps here, the first thing I wrote is, when is v of t equals 0 at time equals what? Time is question at that point. So the first thing I do is I take the function, v of t, from letter A, and I factor it in 2 steps. Step 1 is I pull out the 4, and then from pre-calculus or algebra 2, you should recognize t cubed minus 1 as a cubic, and if you don't remember the formula, you actually have to do polynomial division to get this calculated in here. All right, and I'm not going to take the time in the video to do polynomial division. That's a different skill. The other option I've had students tell me, can't I just set 4t cubed minus 4 equal to 0? And the answer this time is it would have worked, and you would have got the same answer. The binomial here means that velocity is 0 at time equals 1. And that's going to be real important for us going forward. All right? So we just found the particle is at rest at time equals 1 second. All right. Letter D. When is the particle moving in a positive direction? It's asking, when is the velocity greater than 0? And the important part here is you're going to have to use what we learned in the section from part C, when the particle's at rest. Because the question here, and I'm trying to cut it off so we work at it the right way, is when is the velocity greater than 0? At what times? All right? And we know the equation. The equation is like this. And it's important for us to realize that we know when it's at rest. At time equals 1, it's at rest. So I'm going to make a table with signs, S-I-G-N, sign table. And I'm going to use my time 0 because I just like to know what's happening at 0 when time starts. And I know for time 1, the velocity is 0. And you notice I put a little mark in here. All right. Well, if I put 0 in here, 4 times 0 cubed is 0. 0 minus 4, negative 4 feet per second. So between 0 and 1, it's going to be negative. We just showed that here. So I put the little sign, negative sign mark there. And then if I plug in a positive number, or time greater than 1, I'm sorry, like time equals 2. 2 cubed is 8. 8 times 4 is 32. 32 minus 4 is 28. It's positive. I put my sign mark, S-I-G-N, there. And I know then that for the function v of t, which is 4t cubed minus 4, that the places where it is greater than 0, when it's moving the particle forward, starts at 1 and goes to positive infinity. So there's my interval. And again, we should all recognize interval notation at this point in calculus. And if you don't, there's other videos for that. Now, the next two, find the total distance traveled in the first 8 seconds and draw a diagram. It says like figure 2, but I'm going to draw a diagram to illustrate the motion. I'm going to actually draw F first to use to get letter E, because I'm not going to be able to do that. So I have a diagram here. And it's important that we realize what's going on for this diagram. And the important part is this. We know what's happening at time 0. All right? At time 0, when I plug 0 into this function right here, 0 to the 4th minus 4 times 0 plus 1, we know the position at 0 is 1 foot. And because of our work in letter D with the position, I know that my initial velocity here is negative 4 feet. So I drew that as a red line. Initially, this is going backwards. Well, how far along? Well, we know at time 1 it's 0. So until time 1, it goes backwards. That's the intermediate value theorem, right? If a particle is going to go negative to positive, it has to pass through 0. Now, I use the position function, again, up here, to find that f of 1 is negative 2. Awesome. So now I know from time 0 to time 1, it goes position 1 foot to negative 2 foot. Think about it. It travels 3 feet. 1 to 0, 0 to negative 2. We'll get there next. Then we know from our sine table in letter D that it is going forward again from 1 to infinity, which I drew as this black line right here. Well, it asked the distance to 8, so I drew this picture, and I'll put another dot at 8. And I'm going to have to go to the function and do f of 8. And it's a big number. It's 4065. So for the distance, right now I can do it on my sine table if I want. I traveled this distance, then I traveled this distance. I usually like to write it out so I don't make a math mistake. And that's what I did down here with 4e. So I come back to 4e, and I say, my first step of the battle was 1 foot to negative 2 foot, which is 3 feet distance. My next step was from negative 2 feet position to 4,065 feet, 4,067 feet. So if I add the distance here, the distance is 4,070 feet. Let's be clear, one of the common mistakes students make is they give me 4,064, which would be adding them all up. That is a change in position, all right? That is the change in position. That is not the distance. And to end on this note before I end the video, if you're having a hard time understanding distance and position, let me tell you a story about myself so it kind of makes some sense. Every morning I go for a jog. And every day when I brag to my students, I tell them that I ran basically a 5K, but we'll call it 3 miles. All right? I tell them the distance I ran. I ran with a positive velocity away from my house for 1.5 miles. I turned around and I ran a negative velocity back towards my house. My position at S equals 30 minutes. After 30 minutes of running, it's still 0. My position at S of 0 is 0. But at S equals 15, in between, I was 1.5 miles away. Guys, 0 to 1.5, 1.5 back to 0. I don't brag that I had a position of 0 after a half an hour. I brag that I ran 3 miles this morning. Again, position versus distance. Again, there are videos for number 2 already on there. All right, and your workbook will have the odds. So keep practicing. All right, these problems do get easier.